Good morning, guys. Welcome. Welcome to my humble apartment. So it is this part of the year again with the COVID restrictions and lockdown. So we have to work from home. But that doesn't mean that we can't have fun. So welcome. And maybe that's one of the few times where we have a webinar where you can see us. And you can see my lovely plant, my paintings, and I'm very glad that you can only see this half of the apartment, not the other half, because then it gets very messy, but I'm only showing you the good half. So yes, it's that time of the year again. We're working from home, and I hope you're all keeping safe and happy. It's hard, of course, with the holidays and all, but I hope that's the best for us. Hope everyone everywhere is fine, and certainly hope that this is over very soon. But apart from that, I'm very happy today because actually this is one of my favorite kind of content that we do, Radiocrafts. Of course, all content we do at Radiocrafts is very good, but this is my favorite because first of all, you get to see us. Second, it's because I get to interview one of the experts in this field, someone who has tens of years of experience in this industry, has so much knowledge in all aspects of the industry, in the marketing side, business side, of course, the technical side. So any conversation I have with him always teaches me a lot. So in the spirit of Christmas, I thought I'd share that with you. So this morning, I would like to welcome our R&D Director, Ørjan. Good morning, Ørjan.
Good morning, Omar. Good to see you as well.
Yes, how's the weather there? Did it snow where you live today?
Yeah, it's pretty. It's winter has come. Let's put it that way.
So I can see that you have a little fireplace there.
Yes, you will show. I guess it will be more visible later. But yes, I'm sitting here on my fireplace, trying to keep my warm.
That's very cozy indeed. So as you can see from the title slide, today we will be speaking about Mioty. So what will happen is that we thought it's maybe a bit more fun other than just presenting you with information. We would do this in a kind of a Q&A session where I gather questions which from my point of view I think are important for users who are interested in Mioty and want to try it, want to use it. So I'll be asking Ørjan questions about Mioty, and also at the end of this session, you will also be able to ask questions yourself. So please remember your questions, just write them down in the chat window there, and we will do our best to answer them all right after the talk is over. We planned about 30 minutes for the talk and another additional 10-15 minutes for the questions. So I hope you're all ready. We certainly are. So Ørjan, are you ready?
I'm ready, yes.
Some interesting questions there for you. All right, but before dwelling into the questions, just in general, I guess the most easy question, the most obvious, what is Mioty?
So Mioty is still new, I would say, a novel LPWAN. So it's all about getting the long LPWAN range and also ensuring reliability and scalability, which has been the core point of when developing this standard. So it has been developed by the Fraunhofer Institute in combination with Deal, so that they are more the starters of this, but of course now it's an alliance which is driving this.
But this sounds a bit like we have several LPWAN technologies out there in the market. Do you think we need a new one?
Yes, so there is a new need for a new one, and let me just explain that in a bit, because the number of IoT devices is growing exponentially. So that means it is growing by doubling or more than that per year. So when I started working in this industry, it was more machine-to-machine communication, and there were still millions of devices. Now we're talking about adding billions of devices, all operating in the same license-free band. And the license-free band is not expanding while this is expanding. So we will have more and more issue going forward that this is, there are many users of this small common resource, which is the license-free band. And due to that, it's like if 30 people are taking the bus today, that might be fine. If you say that in 5-year time, it will be 300 people taking the same bus, well, you can imagine what will happen then.
It's a very crowded bus.
Yes, so this is what we already seen. When I started working, it was very little background noise when we started doing measurements back in 2005 when I joined Radiocrafts. Now we see it's a lot more noise just in Oslo, and we haven't really hit the boom in terms of IoT devices.
Yeah, with that device, yeah.
So, and it's not just the LPWAN. The LPWAN is growing by like 1 billion until 2023 or something is the projections. But you also have the smoke detectors, the short range metering like wireless Embus or my garage port. They all operate in these 433, 868, 915 bands. So it's not about just the LPWANs. It's a lot of competition of using that market, and that is that's creating problems because it's so much noise. So the question is then, how do you make sure that you get your packets through? How do you make your solution resilient to this noise? And that is, I think, the foundation of why the Mioty standard was developed.
Okay, so that's a very good question. How do you do that? How do you ensure that you get your packets through?
So I can answer this in 2 different ways. So first I can take the business or marketing perspective, and obviously by having long range, it gives long range with better reliability and better scalability. So that means you can have more devices transmitting at the same time, which is hugely important, and doing that all at the cost of lower battery consumption or current consumption, longer battery lifetime. And what that gives you is that when you can avoid, when you can have fewer gateways, when your devices can be in the market longer because they are more resilient to added noise, and also you can the battery lasts longer. That all makes you get more packet through, more data through, and at a lower cost of you as an operator. So it's a business. So that is
business side.
Yes. Yeah, so that's the business side. You basically make more money. That's what all business is about, making more money.
And it sounds very similar to other things that we know about already.
Yes. So I guess a lot of other LPWANs use the same, but there are some major differences here. So now I'll dive a bit more into the technical backgrounds, why and how we accomplish this, because it's these nice marketing words are sometimes just marketing words. So I will show you.
Are you showing us something?
Yes. 1 second. Yes.
Okay.
So these were the benefits I mentioned. The four main benefits, I would say. There are several other benefits as well, but it's about the reliability and robustness and scalability. Those are the 2 really important ones for me. The range, I guess you can have comparable range with other LPWANs technology. So that means if you go to a mountaintop in Norway where there are no other no interference, no other transmitters, you could have others getting the same range, not at the same battery lifetime, but they can, just looking at the range, it's others which are comparable, other technologies. But when combining this with the battery lifetime and the scalability and reliability, that's the unique package we have here. But how do we make this happen? And I think one of the key technologies that enables this is what's called the ultra narrowband telegram splitting ultra narrowband. That means that all the gray parts here you see on my screen are parts of the same packet. This is not 8 individual packets. This is the same data packet being sent, and it's being sent by, first of all, we scramble or whiten the information. the bits, so to mix them so they don't come in a correct order. The second element is that we have a very strong forward error coding that we use, and that's many classes better than the others. So we use a very strong 1 to 3 forward error coding. So that means, and then we split the telegram into at least 24 of these chunks of data that you see.
This is one packet.
Yeah, this is the same packet. So this can only be 10 user bytes. This can typically be. So, and then we spread them over time, as you see on the x-axis here, and over frequency. And that allows us to, or it reduces the risk of somebody by accidentally interfering with this, because they have to interfere over a very long time and over a large bandwidth all the time, and there are no radios which operate in that way. So that means that is they can interfere 1 or 2 of these, but because we have the strong forward error coding, we can lose up to 50% of these smaller data chunks and still get the packet error-free.
50%.
50%. So I guess if we send 24 data chunks, we can lose 12 of them and still receive the packet perfectly. So that makes us extremely robust towards interference. And also, an element that you see here is that if you then send 2 of these packets with some time differences. So imagine that you have two of these Mioty packets coming with 30 millisecond time difference or 40 millisecond. Then they will not collide with themselves. And that's also a very nice feature, that we don't interfere with ourselves as long as there's a slight time difference between two different transmitters, Mioty transmitters. And when you compare it to other technologies, they might be resilient to white noise and stuff like that, or a carrier interference, but they are not robust when it comes to interference from themselves. So if you have 2 transmitters, for instance, of Lorawan transmitting at the same time with the same spreading factor, they are really not good at being interference resilient against themselves.
I understand. Okay. Since we are on the technical side, can you also tell us more about other technical parameters that might be interesting to users? For example, how's the range? Since we speak about losing packets and reliability, so how's the range? How's the power consumption and such important network metrics?
Yes. So the range we often given as a very technical terms as a system value or a system gain. Which in the uplink for Mioty is 154 dB. So that means we could have 154 dB loss between the transmitter and the receiver, basically. And that is that's basically the same as you will have. So it's basically very comparable to what you will get with both Sigfox and Lorawan with spreading factor 12. That is not a higher data rates there, but which they don't have that good range. But so it's in the same division, I should say. So again, if you were in a deserted place where there were no other transmitters, no interference, no city background noise or anything like that, I think they will all perform pretty equal. So if you have one device sending and a desert location, that's one thing, but that's not where most of my IoT cases are. They are typically in a city.
So when you say that, like in a typical scenario, in an imaginary scenario where there's no noise, then all these technologies can be comparable. But when it comes to real life implementations where you have much noise and self interference, this is where Mioty really gets the edge. Exactly. Yeah, I think real life scenarios are good.
But you also talked about battery.
Yeah, how is that? How does that range?
So here it depends which of the LPWANs you're comparing with. Obviously, if you look at if you compare, for instance, to Sigfox or to Lorawan at spreading factor 12, they sending the same amount of data, they have to transmit for 2.5 to 3 times more time than we do. So the packet is 2.5 to 3 times longer. And if assuming that you have the same type of chip technology using the same transmit current, I know some of the earlier deployed devices has higher current when transmitting, but for fairness, let's say that they all have the same TX current of maybe 20 milliamp or something. That means that when they have to transmit for 2.5 to 3 times longer, they will use 2.5 to 3 times more of the battery. And then you can say that there are other LPWANs like using Lorawan and spreading factor 7, but then you're not really talking about that long range anymore. So you have to be careful when you do this comparison to compare apple and apple and not apple and pears sometimes. So that's
I think also Christian here in the chat window is saying that Mioty will be more reliable in achieving range because it has 24 sub-packets, of which only 12 need to arrive. And that also sheds light on what you said about reliability, that only 50% of the sub-packets need to arrive for you to decode the whole packet. So 12 and 24, that's kind of also the same.
Yeah.
Yes, we agree with you there, Christian. So staying also with the technical parameters, spoke about range, about the battery consumption. But I think one of the most commonly spoken about topics and questions asked, not many people explain that, is security. So how does Mioty deal with the security? How does it provide the security for the users?
Of course, being a new standard, of course, security has been thought of from day one, obviously. So there are 2 different layers of security. You have something called a network security, which is, of course, unique per device, which is both encryption and authentication of a device towards the base station or the gateway, as we call it in Mioty. So that is the one layer, and that has to be known by the operator, or has to be known by the operator of this device as well as the device manufacturer. But then you can, in addition, you can add application layer security on top. So that means you have 2 layers of security, and all this is done with AES 128. So it's kind of on security, it's kind of more following industry standard. We are not. I don't think we have invented something spectacular, but we are following the best practice in the industry at the moment, which is a very good solution, I would say.
I understand. Okay, so in light of all the different parameters you spoke about and what Mioty provides, but the IoT market is very diverse, and the applications and the use cases are very diverse, and they vary a lot, and each application has its own certain requirements. So in light of what you just said, what kind of application do you think Mioty suits the best? Like, if I have what kind of use case, do I say, yes, Mioty is the way to go?
Yes, I'm just sharing something again with you, Omar. Obviously, as it is today, it is best suited for uplink dominated use cases. That means uplink means that there are a lot of sensors sending data to the cloud or to a common base station. That means it do have 2-way communication. So, but as we will talk about a bit later, no LPWANs is really suited for a lot of 2-way communication. Obviously, because of this the scalability, where you can have 1.5 million devices per 100 kilohertz band, which is far more than the other LPWANs can have. It's very suited for applications where you have a large number of devices sending data often. So that means I've heard about buildings in central Oslo here where they have 1,500 sensors in one building, and if they each send every 50 minutes, it's kind of high density in terms of packets. So as I said, 1.5 million packets per day is what we basically can handle. Also, it's quality of service oriented products, so or services, I should say, because we different applications have different need of delivery rate or quality of service. Some say that sometimes you say that, okay, if I get every second packet, then I'm happy because I don't really need to get all the packets all the time. While others, you have to say that if you lose 10% of your packets, your service isn't worth anything anymore. So that's kind of important to understand what type of service or what type of business are you using this data for. If this is critical data, critical infrastructure, you cannot lose a lot of packets. Then you have to, and maybe the network you're deploying will stay there for 5 years. I would be very concerned with choosing something else than Mioty, because how will that system perform after 3 or 5 years with more noise coming?
Yeah. So at this point, again, you're like speaking about what you said earlier about the future and how the bands will be so crowded in the future. So Mioty is like very good idea for a future perspective or a future investment, that in the future things will get worse in terms of noise and interference and so on.
Well, yeah, but there is a lot of interference today. Just to point that out, it's not something which is coming. There's a lot of interference already today.
It's already happening.
Yes, it is happening. So it's not something in a far distant future. But quality of service is important, and we do see that when you stack a lot of devices in, we see that comparison studies done by a university in Germany show that Lorawan started to lose 5 or 10% of packets before Mioty started losing 1 packet in the same setup. So so it is. It's already showing today in tests today to be much more resilient to noise and to scale and to many devices. Also, you have to consider your project. But what you talk about the future is how long will your network be operating? Will you be shifting out your gateways in 2023, or do you plan to change them in 2028? If you want to have them in 2028, how many IoT devices is projected to be in the market by 2028? That's like, I don't know, I'm not sure how many billions. So I guess anybody can guess a number, but that's also important. And also because it's very good for battery operated devices, that is something we also recommend. So but we have to be fair, it's not all use cases which are good for Mioty. So if you have very much control, very much downlink packet going down to network, obviously that's not very scalable with many devices. So we do see that for intensive control application with a lot of control data going down, we see the customers chooses more mesh solutions and these kind of things. Also that there is like a 5-6 second delay from you send a packet because it's spread over so long time and over so many frequencies. There is a 5 seconds delay, 6 seconds delay of sending a packet. So it can't be like real data or like precision controls in terms of that that needs millisecond timing.
I see that many LPWANs are not really optimized for downlink kind of traffic.
No, and that has to do with the fact that it has to do with 2 things. One is the fact that LPWANs, you have a gateway, and the gateway, when it transmits, it will not be able to receive. So that so that when you transmit something, you're basically deaf. You cannot pick up and hear things at the same time. So that means if you, for instance, wanted the normal way, for instance, to do quality of service in short range communication is that the device sends an acknowledgement, the gateway sends an acknowledgement, and you retransmit if the packet isn't received. But you cannot do that, because if you have 1,000 devices sending messages every 10 minutes, that's 6,000 packets for every hour. And if you want to transmit an acknowledgement to each of them, you're basically busy transmitting most of the time. So you can't listen and can't receive all the incoming data. So that's one thing that you don't want to send too often, either acknowledgement or control data, because it prevents you from receiving. The second is that the gateway is one device, and in Europe specifically, we have the challenge of duty cycle limitation. So that means the gateway cannot send too much of the time, but then it violates with the duty cycle regulation in Europe. So yeah.
Oh, I see. What else did I want to ask you about? You know, with the other LPWANs, it's kind of a big ecosystem with many players in the market, and it's kind of this like big alliances and so on. How is Mioty doing in that regard?
Yeah, there's also Mioty Alliance, but the Mioty Alliance is.
I'm sorry, but we can't. I don't think I can see you anymore. I'm not sure if it's only my problem, or maybe you can turn off your camera, turn it on again, or something.
Okay, I do see myself here, but anyway, the Mioty Alliance is. Well, say rather new compared to the others, so it's the new kid on the block. It's actually younger than a COVID virus, so that's a bit. So that's to explain how young it is. So it's an ecosystem. It's called Mioty Alliance. It's growing month by month, but of course, in terms of deployments and commercializations, the other LPWANs, which started in more 2010. Have of course come further in and have more deployments and stuff like that. So we have to be fair about that part. But yes, we are growing. There is now 3 or 4 chip vendors which have chips. You have several module vendors. You have the number of gateways was 1 when we started. Now it's 5 or 6 different gateways which are available. So it's there are softwares available, software stacks available. And there's a big activity in the Mioty Alliance to further also develop the standard. Now it has been developed on the physical layers and stuff like that, but there's still a lot of work being done in the Alliance to include the more network management side of things, applications, the application level standardization. We have the expanding to new bands which are coming. So there's a lot of activity ongoing. There's also press release on the Alliance webpage about this downlink only modules where you have more time synchronized devices. So there's a lot of activity and a lot of in the Alliance, both in terms of new product, but also further develop the standards. And but as I mentioned, it's still early days. So the standard will still be improving, but it is deployable as it is now. So it is ready to go to market now. But there will be other parts added in the future to make it even more robust.
Okay, that's always nice to know when a standard is like starting and on the way up, and things will just keep getting better in the future.
Yes.
So we spoke about many things, but there's one important name that we didn't mention today till now, which is Radiocrafts. So what does Radiocrafts offer with regard to all this?
Yes. So first of all, we are not like the inventors of Mioty, but we are having been in the IoT business for 20 years now. We do see we do know the market very well. We do see the need for these solutions. So we did identify it as a good added technology to our portfolio, because we didn't have exactly this technology to meet the market requirement. So of course, Radiocrafts is a module manufacturer. So we offer our modules, which are preloaded with with the firmware. So it is a AT based command set. So this is now out already. This is actually an old slide, so I have to apologize for that. And then we're also looking at adding this with a more application, the Mioty 2, which is a module where customer can write their own application inside the module. So we have the modules, which is then including the chips and the software and everything to communicate with the gateways. And we also have the development kits, so the customer can test this now. So this is available on DigiKey, so people can order the device development kit today. Of course, we also, as we do with a lot of other modules we make, we also have, we offer support, we offer customization, we offer tailoring to customer needs, so that we make sure that the modules is doing exactly what the customer wants.
Okay, that was very good. I think I ran out of questions exactly on time, which is something very good. I like being on time. And I really learned a lot from all this, Ørjan. Thanks a lot.
I see we have a lot of questions from our listeners.
Yeah. Let's have a look. I think down are the first ones. So, for example, this question from Paul is saying, can I do simple point-to-point communications, or do I need the gateway devices?
Yes, so the answer is there that no, you need the gateway devices, because so that is kind of the concept of Mioty, is that you have a gateway or a base station gathering this data. So yeah.
Then Kushi is asking about indoor range.
Yes, and yeah, that's always a difficult question to answer, because it depends so much on
how thick the wall is,
how thick the wall, how many of the walls, how is there every different floors in the building, what's the background noise, so it's really an impossible question to answer, but we have seen applications where customers can easily cover a building of 15-20 floors or something like that with one gateway. So you should basically cover. It should be a very big building with very thick walls if you cannot cover the whole building with one gateway.
And that's why we have development kits. That when you order a development kit, you can always test that very easily in your office. And because I think it also matters a lot what the walls are made of. I think in our office at Radiocrafts, the walls are a bit thin. Like if you knock on them, you will hear a very loud noise. But like concrete, like at home, if you knock, there's nothing, nearly no sound. So that means it's very thick. So then it would have less penetration. So it depends like that. Then Paul is also asking about the packet size.
Yes, I wasn't sure what you mean with the packet size in terms of bytes or length in millisecond, or I think if I remember correctly, I don't remember if it's 128 or how many bytes you can send in one packet. The default is kind of that we use in all the calculation of current consumption is 10 bytes, but obviously you can send a lot more. But then, so what we know is that 10 bytes result in an on-air time of like 300 millisecond, 320 millisecond or something like that. So obviously going to even longer packets will obviously lead to longer airtime. But so maybe Paul can refresh a bit. So maybe we can go to the next one while we see if Paul adds some more information.
Speaking about the downlink, Christian is asking about how feasible it is to have firmware updates. I'm guessing he means over-the-air updates.
Yes. So Yeah, of course, the data rate is not huge, so obviously it will take a lot of time. So I mean, if you have 20,000 devices in your network and want to upgrade them, then at the moment there's no common broadcast windows, so they can't be synchronized. So obviously that will take like forever. So of course, with any LPWANs, doing a firmware upgrade takes a lot of time. So yeah, that's basically how it is. So what we are looking at now is, and we will come with that we work on now, is also that we combine Mioty together with BLE to make sure that we also have radio modules will also support BLE, so at least you can use the BLE for over-the-air upgrades, which of course is not the same, because you have to go around with your cellular phone or some device which have BLE connection, but at least that's an opportunity.
Okay, then Antonius is asking about the link for study. I'm not sure which study. So maybe Antonius,
I think the only study I mentioned was this in Germany. So I will send it to. I don't have it right here, so I will send it to Antonius afterwards. So I will make a note of that.
Okay. All right. Let me just have a quick look. Some upload. Paul, I actually have a question for unit costs. I think you can contact sales at radiocrafts.com. I think they can better answer this kind of question, since we're mostly dealing with technical things. And yeah, sales would definitely give you better answers. Okay, so Paul was asking, same upload and download size of packets and repetition times. Maybe that's a follow-up on something you were saying?
Yes, so yes, the data rate and stuff is the same uplink and downlink. So and I think the overhead is pretty much the same. So it will be the same uplink download sizes. Repetition time 30 seconds had to do with I think it was a slide showing that it has to do with CE regulation. So if you send 10 bytes every 30 seconds, that's basically what you're allowed to send in terms of CE approval or duty cycle on the end devices, not on the gateway. But of course, if the gateway is sending down to, you can only send down 30 every 30 seconds as well. And that means it cannot send down every 30 seconds to each device, because if there are 1,000 devices, that basically makes it busy all the time. But yeah.
So also Christian is asking about if we believe Mioty will displace Lorawan.
I don't think it will displace Lorawan in like a short term or not. I think they will both.
It's a very hard statement.
Yeah, I think they will both live happily side by side. I don't think there is either or here. I don't think there is. Obviously, there could also be business cases which are or deployment cases which are better with Lorawan. So I'm not saying this is better for all use cases, but and will the problems with noise in the background be so big that basically a lot of the other technologies will start to struggle? Maybe. It's a bit hard to predict the future. It's as always, but I don't think it will displace Lorawan. No. We can also comment on the unit cost here, because we already have more chip vendors here than are available for Lorawan. So obviously, when you look at the big deployments and the chip pricing in terms of over time, obviously it should be better. Both the chip and module prices should be better over time than LoRa, of course, or Sigfox for that matter. But of course, currently the other LPWANs are probably doing larger volumes, so that means it might not be cheaper on the short run.
Mhm. All right. To change names, I think I see Marek Novak is mentioning the topic of multicast, saying if it is supported and that it would be very hard, especially for something like firmware updates regarding the downlink you spoke about.
Yeah. Yeah, there is work ongoing now to look at these listen-only devices, which are then time synchronized, so they wake up at certain time to listen. And obviously, when you have listen-only devices which are synchronized to the gateway, obviously, if then they're all synchronized to the same time slots, you should be able to do. But this is kind of a bit ongoing studies in the alliance to look at this, so it's hard to say how the solution could be in the future. There's also a question. There's also a question from Tony on successful deployments.
Yeah.
There has been done these different studies, so I think a lot of them are. If you look at the Mioty Alliance.com, you'll find several case studies there where they have deployed the systems and have some experience from it. Yes, I would. There is some deployments already, and I think you can find some case studies on that on the Alliance webpage.
Mm-hmm. Tony was also asking about the Mioty Alliance, since it's still young and maybe it has some gaps, it needs to be filled. So what kind of companies do you think can join the Alliance? It's a bit hard to predict.
Yes, so I think there will be more end users joining moving forward, and I also think there are room for more gateway suppliers, and also companies doing more like back-end software type of thing and services and these kind of things. But there's room for everybody.
Do you think the Mioty protocol is open sourced? Can someone implement it on an SDR? From Novak asking that.
I think it's a bit challenging question. Of course, the Mioty standard is ETSI standard, so it is basically public available how it works. So basically, everybody can implement it based on those on that standard. But I think it's pretty hard to implement it. So I would normally recommend that you use the available software which is available basically for both the gateway and the end devices.
All right. See, guys, I told you can ask about anything. Like, he knows so many things about the whole aspects of this industry, and it's just amazing.
We did have a follow-up by Paul about the payload size in terms of bytes.
Did I know that? Yeah.
And I tried to find it here, but I couldn't. So I guess I have to come back to you about the max payload size. I should have had that, but I don't remember. Okay,
so I hope you guys enjoyed this as much as I did, and thank you all for joining. And it's very good that we had it exactly on time. We are now exactly 10:45, so we did manage to get everything on time, which is always very good. Hope you guys learned something from this, and remember that this webinar is recorded and will be available on our website pretty soon. So there's a new question which is very relevant from Paul. Where to start? Where would you point people to start experimenting with Mioty?
Yes, so they can visit the Radiocrafts.com to find about our development kits, which will be good starting, and then they need a gateway as well. So I would then recommend going to the Mioty Alliance homepage, where you will find a selection of the available gateways. So basically that's where you get started and try to play with it and see how well it works, and then take it from there.
Okay, thank you guys for joining. Thanks for listening. And Ørjan, thank you for your time. Thank you for your knowledge that you shared with us today.
Yes, it was very nice being here. And when we are at home due to these COVID restrictions anyway, it's good to spend the time doing something useful and talking to the customers, even though they cannot directly talk back. But that's always good.
Okay, so thank you all, and wish you a very nice end of the week and a nice weekend, and see you in the next webinar next year. Till then, have a nice Christmas and a very happy New Year. Bye, guys.
Bye-bye.